Hello dear students, this is Dr. MANASI MUKHOPADHYAY. Today I'll be trying to put some light on one of the periodic properties of the elements, namely ionization energy. Now the thing is, first we have to have an idea about what do we mean about saying ionization energy. Actually, by definition, ionization energy is the amount of energy that is required to leave one electron from the outermost orbit of an isolated gaseous atom. It is some point of time it is also known as ionization potential. Rather earlier it would have been known as ionization potential, but today's reference it is known as ionization energy. And we must say that the removal of the amount of energy required to remove the first electron from the outermost orbit of an isolated gaseous atom is known to be the first ionization energy. Here we can see this is the nucleus. Here we can see from the pictorial diagram, you can see that the central position, which is red in color, that shows the nucleus, which is positively charged, and around this there are different electrons rotating in different orbits. So you see there is an arrow mark at one of the electrons. If it is ejected out, if by any chance it can be ejected out, and for that ejection the amount of energy required will be termed as ionization energy. Now, as I said, ionization energy for the first removal of the first electron, it would be called first ionization energy. When it comes for the case of the second electron from the immediate next orbit, it will be called second ionization energy, and so on. Here there is a mathematical representation. F is proportional to Q1 into Q2 by R square. Q1 and Q2 are the two electronic charges. R is the radial distance between them. So you can see that the larger the F, more difficult is to remove the electron. That is, higher amount of energy is required and larger ionization energy is manifested. Moving on to the next slide, what we can see, rather how we can even further define ionization energy is that in more technical term, we can describe ionization energy as the minimum amount of energy that an electron requires, that an electron of an isolated gaseous atom requires to be removed from its outermost orbit. And this is very much influenced by the nucleus of the valence shell. It is also sometimes referred to as the ionization potential, as I said, and it is always an endothermic process. That means energy is required to perform this process. I hope we all are very much knowing about the endothermic and the exothermic processes. The process in which heat is released, that is exothermic, but in this case the amount of energy or heat, whatever you say, that is required to be absorbed to remove the electron from the outermost orbit. So it is obviously an exothermic process. And ionization energy, moreover, gives an idea of the reactivity of the compound. It can also be used to determine the strength of chemical bond. How strong the bond is, that can be very much depicted from the value of this ionization energy. And traditionally, the unit of ionization energy is kilojoule per mole. If we go on to the next slide, we will be understanding, or rather we will be getting an idea about what are the factors on which ionization energy depends. It is very much predictable that the more the amount of energy required to release the electron from the outermost orbit, higher is the ionization energy. Now we have to understand what are the factors on which the amount of ionization energy or the value of the ionization energy increases. The first and foremost thing is the nuclear charge. That is the charge present in the nucleus, the positive charge present in the nucleus. Higher the positive charge is, the value of the positive charge, higher the nuclear charge, more is the ionization energy. This is because more the charge of the nucleus, it will be attracting the outermost electron in more severe way. So the electron at the outermost orbit will be held more tightly. Naturally, more energy will be required to release that electron from that, out of that isolated gaseous atom. And this can also be represented by a term very much known as effective nuclear charge, Z effective. What is it? It says that as the effective nuclear charge is higher, the size of the atom decreases, because as the nuclear charge increases, the number of electron also increases, because we know in order to maintain the electrical neutrality, equal number of the electron and the proton must be present there. So as the nuclear charge increases, naturally you may ask, if the nuclear charge is increasing, the electronic charge will also be increasing, and it would be of the same value. But you have to understand, in this case, the effectivity of the nuclear charge is more higher than that of the negative charge. So higher the nuclear charge, more will be the electrons attracted and the size will be shrinked. As it will be closer to the nucleus, the outermost electron will be closer to the nucleus, it will be held more tightly, and naturally more energy will be required to release that outermost electron from the orbit. Second comes is the nuclear shield. What do you mean by shield? Shield is something what we can explain as a cover, the layers. So as the number of layers or the number of orbits from the nucleus increases, the shielding effect increases. The electron outermost orbit is more shielded, and naturally the effectivity of the nucleus to drag the electron towards itself reduces. And as the electron at the outermost orbit is less tightly held, lesser amount of ionization energy will be required to release the outermost electron. Third one, what we can say is the electronic configuration. What do you mean by saying configuration? Configuration is nothing but the arrangement of the electrons in the orbit or in the element. So as we know that the element is heading towards if it is having a stable configuration of the outermost orbit, either 2 or 8, then naturally there will be more amount of energy required for this electron to be released, because the stable configuration gives the element or the nucleus the stability, or the element the stability, and no one tries to release its stability. Stability is of utmost important thing. No one is ready to leave to sacrifice its stability. So is the case for this element as well, which is having stable electronic configuration. Number 4, we can say that arrangement of electrons. We know that orbital electrons have subshells. If the electrons are paired, then naturally they are in stable configuration, so more energy will be required to release the outermost electron. And last one, if the orbital is either half filled or completely filled up, it attains maximum stability and it is no way ready to release one of its electron, ready to sacrifice one of its electron. So in that case, if it needs to sacrifice the electron, more amount of energy should be given to the element to remove its outermost electron from the outermost orbit. So these are the factors which influence the ionization energy. Moving on to the next slide, what we find the trend of the ionization energy in the periodic table. As we see from this periodic table, it increases from left to right. As we move from left to right in the periodic table, ionization energy increases. And as we go down, ionization energy decreases. Why so? It can be easily explained, because as we move from left to right, the nuclear charge increases, and as the nuclear charge increases, the distance, the atom becomes smaller, and the distance between the nucleus and the outermost electron decreases, and the effective nuclear charge increases. And as the effective nuclear charge increases, more energy will be put forward to release the electron at the outermost orbit. And what is the case for decrement of the ionization energy towards the down while we move in the periodic table? This is because this can be very simply explained and very logically explained by the shielding effect. As I said, shielding means number of increment in orbits. So, as we remain in the first period and as we go to the second period, number of orbit increases. As we move on to the third period, even more the number of orbit increases. So, as we go on down the period, number of orbits increases. And these increment in orbits put a shield between the nuclear charge and the outermost electron. So naturally, as the shielding effect increases, the attraction or effective nuclear charge between the nucleus and the outermost electron decreases. And as it decreases, the outermost electron can be readily taken out with a small amount of energy input. That is why the trend is somewhat like this. As we move on in a periodic table from left to right, ionization energy increases as the effective nuclear charge increases because of the shortening of the size of the electron. And as we move from top to bottom, the ionization energy decreases because of the decrement in the value of the effective nuclear charge due to shielding. Now from this discussion, what we can understand, which one of the elements in the periodic table is having the highest ionization energy? We can readily say it is helium. And which one is the lowest? It can be seen it is francium because it is in the lowest in the periodic table. Here are the values of the ionization energies of the different elements, first 20 elements of the periodic table. This is simply a value. You don't need to remember this. This is just for your knowledge. And here are some irregularities of the ionization energy. Helium is having an electronic configuration of, beryllium. Beryllium is having an electronic configuration of helium plus 2s2. It is having lesser value of ionization energy, higher value of ionization energy. Why? Because it is having completely filled up electronic orbital and having a stable configuration. So it is very difficult to release or to remove the outermost electron from the beryllium atom. Whereas boron is having lesser ionization energy in the periodic table. It has got p subshell neither filled, neither completely filled up nor half filled. So it is very much easy for someone to release this one electron available in the p orbital. And these are some examples, nitrogen and oxygen and so on. And as I said, these are the indications of different ionization energies. When boron releases one electron, it becomes B+, having ionization energy of 801 kilojoule per mole. This is called the first ionization energy. Again, then B+ removes further electron to produce B2+. It is second ionization energy, having a value of 2427 kilojoule per mole and so on. The higher the charge of the parent species, the larger is the ionization energy. More difficult, and it is more difficult to remove an electron due to the increased attractive force between the nucleus and the outermost electron. And that is all about this discussion on ionization.